Hello everyone, my name is Arohi and welcome to my channel. So guys, in my today's video I'll talk about what are transformer networks and how transformer network works. So to understand how transformer network works, let's understand the concept of attention. Imagine you are trying to translate a sentence from English to French. When you translate, you don't just look at each word in isolation. Instead, you pay attention to the context and the meaning of the entire sentence. You give more importance to certain words that help you understand the sentence better. This is what we call attention, right? Now let's take another example. Imagine you are watching a movie and you want to understand what is happening in a particular scene. When you watch a movie, you don't just focus on single frame, right? So you pay attention to the sequence of frames and then the actions of the characters, and you understand the overall story. Okay, this helps you understand the context and the meaning of the scene. Okay, so a transformer network is designed to mimic this process of attention. A transformer network uses attention to understand the sequence of information. Instead of frames in a movie, it could be words in a sentence, notes in a music piece, or even pixels in an image. Okay, so the transformer network can capture the relationships and dependencies between the elements even if they are far apart. Okay, so this ability to capture long range dependencies is what make transformer network powerful for tasks like language understanding, where the meaning of a word can depend on words that appear earlier or later in that sentence. Okay, so transformer network consists of two main parts, which is encoder and decoder. Now let's understand encoder and decoder in detail. So let's assume we will understand the encoder and decoder part with an example. Okay, so let's assume we have a task. We want to use a transformer to convert the sentence from English to French. Okay, and input to transformer. In this case, if you want to perform this functionality, you want to convert a sentence from English to French. In that case, the input to transformer will be a sentence. Suppose we have a sentence, the cat sat on a mat. Okay, so in the first step, what will happen initially? Okay, so first step will be tokenization. So tokenization simply means the input sentence is first split into individual tokens. In this case, the token would be like this. And once you have the tokens, then we will perform word embedding. Now, word embedding is, you have tokens now. Each token is then converted into a dense vector. Okay, dense vector representations called word embedding. These embeddings are capturing and representing the relationship and similarities between the words based on their meanings. Okay, so let's assume that you have a pre-trained word embedding model with you. For the vocabulary which you have a pre-trained word embedding model for that. So after applying word embedding, we will get a series of vectors like this. For this, for cat, this will be the vector. Okay, so this is how we get the word embeddings. Now you have the word embeddings. Next step is we feed all these words of the sentence at the same time to our network. Okay, what happened in transformer is, you have a different words in the sentence and we feed all the words at the same time to the network. Okay, so that means that the transformer network don't have any idea of word order, because we are sending all the words together. So transformer don't know which word comes before or after any particular word. Okay, so for now, what we are using is, we are using positional encoding, and the purpose of positional encoding is to help the transformer model to understand the position of the words in a sequence. Okay, so we have a sentence, so which word is coming at which position, this task is done by positional encoding. Okay, positional encoding is added to the input embedding which we have, right? before they are processed by the transformer layers. Means right till now we were not at that stage. We are not using encoder or decoder of the transformer yet. We are at the very initial step where we are just preparing our sentence in that format which our algorithm will accept. Okay, so that is, we convert the sentence into a tokens. Then from those tokens we used word embeddings, and after creating a word embedding we are using positional encoding so that we can send the position of each word in a sentence with the words. Okay, so for that we are using positional encoding. Now we added the positional encoding. Positional encoding is also a set of additional vector that convey positional information. Okay, and after applying positional encoding, the updated vector could look like this. So guys, just assume I'm just showing you the random example, means you will get this kind of vector after it. Okay, so for each word. Now positional encoding is done. Now the next step is encoding layer. So the transformer network have 6 encoders and 6 decoders. You can see the architecture over here. So now we will talk about each and every layer which is there in encoder, and then we'll discuss what is there in decoder. Let's start with the encoding part. So the input sequence is passed through multiple encoders. Okay, so which input sequence? The input sequence which you will get from the positional encoding. Okay, so each encoder consists of self-attention mechanism and feed-forward neural network to capture the contextual information and dependencies between the words. Okay, so now let's understand this multi-head attention layer. What is this multi-head attention layer? This is the self-attention task. Now let's understand what this layer is doing exactly. So in transformer model, the self-attention layer plays an important role in understanding the relationship between the words or tokens in a sentence. It helps the model to figure out which words are important to each other and how they relate to one another. Okay, so here now let me show you how this self-attention layer works. Okay, now we are again understanding this self-attention layer with example, and we are working on the same example sentence, which is the cat sat on a mat. Okay, so the self-attention layer takes the word, okay, take all the words which are there in the sentence, and each word will be assigned by 3 special jobs. Okay, so every word in the sentence will have 3 different tasks, which is query, key and value. I will explain you what is query, key and value. First I'll tell you in brief, and then I'll elaborate you these things. Okay, but just remember, when you're working with self-attention layer, in self-attention layer each word will have 3 jobs, which is query, key and value. Okay, now what is query? Query is like a word looking for other words to pay attention to. Okay, so, clear? A word looking for other words to pay attention to. And key is like a word being looked at by other words, and the value is like the information or meaning of that word. Okay, so each word in a sentence get transformed into query, key and value. The word will have a query, key and value. Cat will have a separate query, key and value. Like this, each word will have a each word will get transformed into query, key and value. Okay, and this will be done by some maths. Today we are not discussing that math, we are just understanding the overall idea. Okay, so now the self-attention layer looks at each word and compare it to all the other words in the sentence. Okay, and see how they are related to each other. Okay, so then this self-attention layer calculates a similarity score. Okay, so what this layer does, it calculates the similarity score between each word's query and all words key. Okay, don't worry if you don't understand this sentence right now. In a minute I'll show you the example and you will be clear with this. Okay, for now just remember how this similarity score will be calculated. Each word's query and all other words keys will calculate the similarity score on the basis of this. The higher the score, the more related the words are. These similarity scores are then used to determine how much attention each word should give to other words in the sentence. Okay, the words with the higher scores will get more attention. And then finally, the self-attention layer combines the value of related words based on their attention weight. It creates a new representation for each word by considering the meaning of the related words. Okay, and by going through this process for every word in the sentence, the self-attention layer helps the model to understand the relationship and dependencies between the words. This understanding is crucial for tasks like translation, summarization, understanding the meaning of the sentence. Okay, so the self-attention layer allow the transformer model to pay attention to different parts of the sentence and understand how words relate to each other and capture important information for further processing. Now let's the overall theory which I've just told you, let's understand this with example, and we are working on the same sentence, the cat sat on a mat. Okay, so this is the sentence, and this sentence is with now self-attention layer. Now let's see how self-attention layer will work on it. Okay, so till now we know that we use the first we have sentence, we convert it into tokens, and then when we have word embeddings, and then we add positional encoding with it, and then that becomes the input to a encoder. And encoder's first layer is self-attention layer. So the first layer of self-attention layer, the initial encoder, there are 6 encoders, right? The first encoder and the first layer of first encoder is self-attention layer. And what will be the input to the self-attention layer now? The input embedding, where we have the positional encoding also. Okay, so now each word will have a query, key and value. This I have told you that self-attention will give you these 3 things for every word. Okay, so we are working on one word. So let's talk about the cat word first. So we are not going for the entire sentence, I'm just showing you how it works with a single word. Okay, so for example, for the word cat, the query, key and value is this. Okay, similarly we obtain query, key and value vectors for each words in the sentence. Now we will calculate the attention. Okay, the self-attention layer compare each word's query with the key of all other words to calculate similarity scores. Okay, for example, to calculate the similarity score between cat and mat, the query vector of cat is compared to the key vector of mat to determine their similarity. Okay, so as I've told you earlier also, the query vector represents the word that is seeking information. Okay, or you can say attention from other words, and then the key vector on the other hand represents the word being evaluated or looked at by other words. Okay, the key vector holds information that can help determine the relevance of the word to the other words in the sequence. Okay, so after that we have attention weights. Now the similarity scores are transformed into attention weights using some mathematical operations called softmax. For example, the attention weight between cat and mat might be 0.6, indicating that cat pays 60% attention to mat based on their relationships. Okay, now the weighted sum, let's see what will be there in the weighted sum then. The attention weights are used to compute weighted sum of the value vectors. For example, the weighted sum of values for cat would be calculated based on the attention weight of 0.6 with mat. Okay, so then after that the weighted sum is the updated representation of the word cat, taking into account the attention given to other words. The updated representation captures the context and the meaning of the cat considering its relationship with other words. Okay, so this process will be the above steps which I've told you. The above steps are repeated for each words in the sentence, capturing the attention, and then updating the representation for all words. So by going through this entire process, the self-attention layer helps the transformer model understand the relationship between the words, okay, and then capture the important contextual information. This allows the model to make better predictions and understand the meaning of a sentence more effectively. Okay, so this is what self-attention layers does. Now if you'll see encoder, you'll see that we have add and norm layers in add and norms layer, right? So this add and norm layer applied after the multi-head attention layer and the feed forward neural network within each transformer encoder and decoder. If you'll see encoder and decoder, and you can see that we are using this add and normalization layer. Okay, so these layers play a crucial role in facilitating the flow of information and stabilizing the training process. Okay, so what add layer does? The add layer, also known as residual connection or skip connection, perform element-wise addition between the output of the previous layer and the output of the attention or the feed forward sublayer. Okay, the purpose of this addition is to preserve the original information from the previous layer, which allowing the model to learn and update the new information captured by the sublayer. Okay, by adding this output of the sublayer to the original input, the add layer enables the model to have the shortcut path for information flow, helping in the efficient propagation of gradients during training. Okay, so this mechanism assists in addressing the vanishing gradient problems and allow the model to learn more effectively. Okay, so now let's see the normalization layer. The normalization process helps in stabilizing the training process by reducing the impact of input variations and improving the generalization ability of the model. Okay, so the combination of this add and the norm layer in each transformer layer allows for better information flow, gradient propagation, and stability during the training. These layers help the model effectively capture and process information, enabling the learning of complex patterns and the relationships in the input data. Okay, so this is what encoder is, right? So guys, now let's discuss what decoder is. So we have 6 encoders. In the same way we have 6 decoders in transformer network. So let's understand what decoder is, how it works. Okay, so decoder is essential part of transformer architecture that is responsible for generating the output sequence, such as translating a sentence or from one language to another, or generating a response in a chatbot. So basically how it works, it receives information from the encoder which has already been processed, the input sequence, right? So now you'll see we have self-attention in decoder also. We have in self-attention in encoder, in the same way we have self-attention in decoder also. Now the decoder use this self-attention to understand the relationship between the words in the output sequence it is generating. Okay, so it attends to different words in the output sequence to capture dependencies and determine their relevance to each other. Okay, so then we have masked self-attention. Okay, see, we have self-attention, and in decoder we have another thing which is masked self-attention. Now what this masked self-attention does, in the decoder a special type of self-attention is there which is called mask attention. Okay, and this mask ensure that each word in the output sequence attends only to the words that comes before it. Okay, it is just preventing it from peeking into the the future. Okay, so by doing this, why we are doing this? Because by doing this, the model generate the output sequence one word at a time, considering only the information available up to that point. Okay, This masking is essential because during training or inference, decoder generates the output sequence one word at a time and should not have knowledge of the words that have not been generated yet. Okay, so by attending only to the preceding words, the decoder can focus on the available context and make accurate predictions based on the information it has, it has at each step. All right, so this is the basic idea of decoder. So once the decoder has calculated the attention weights using mass self attention, okay, it computes a weighted sum of input representations from the encoder. Okay, so this weighted sum captures the relevant information from the input sequence that helps in generating the next word in the output sequence. Okay, and then we have feed forward networks. The weighted sum is then passed through a feed forward neural network. This network applies some transformations and non-linear operations to further process the information and generate a more refined representation. Okay, so the output of the feed forward network is used to predict the probability distribution over the vocabulary, indicating the likelihood of each word being the next word in the output sequence. All right, and the word with the highest probability is selected as the predicted next word. So this is an iterative process. Okay, decoder repeats these steps iteratively and generate one word at a time until the desired output sequence is produced. Okay, and by using this self-attention, mass self-attention and feed-forward neural network, the decoder in the transformer model can effectively generate output sequences based on the information received from the encoder. Okay, there is one more thing to explain, that the output of the encoder is the input to decoder, right? But if you check the architecture, you will notice that output of encoder is becoming the input to multi-head attention, which is the second layer in every decoder. Okay, so what is the input to the mask multi-head attention? So the input to the mask head multi-attention layer is the decoder. So we have a decoder, right? Every decoder has a self-attention layer. So the output of the self-attention layer will become the output to the mask multi-head attention. Okay, so guys, this is how this transformer network works. This is the main idea behind the transformer, and yes, that's it. So if you have any queries, you can ask your questions in the comment section, and I hope this video is helpful. So guys, if you like my video, please like, share and subscribe my channel. Thank you for watching.